Solid principles. Solid is a set of 5 design principles that promote well-structured, maintainable, and flexible object-oriented code. By following these principles in your ASP.NET Core applications, you can make your code easier to understand, modify, and extend. 1. Single Responsibility Principle, SRP. What it means. A class or function/method should have one and only one reason to change. Put simply, each class should focus on a single, well-defined responsibility. Benefits. Improved code clarity, easier to understand what a class does. Reduced complexity, changes in one area are less likely to impact others. Enhanced maintainability, easier to modify and extend classes without unintended side effects. Example in ASP.NET Core. Instead of having a product controller handle both product data access and view logic, create separate product service and product controller classes. The service handles data access, while the controller focuses on processing requests and mapping data to views. 2. Open/closed principle, OCP. What it means. Software entities, classes, modules should be open for extension but closed for modification. This means you can extend functionality by adding new classes or behaviors without modifying existing code. Benefits. Increased flexibility, easier to add new features without breaking existing functionality. Improved code reusability, existing code can be leveraged without modification. Example in ASP.NET Core. Define interfaces for common functionality like data access or logging. Implementations of these interfaces can be created for specific databases or logging providers without modifying the core logic. 3. Liskov Substitution Principle, LSP. What it means. Objects of a subtype, derived class, should be replaceable with objects of its supertype, base class, without altering the program's correctness. Subtypes should be consistent extensions of their base types. Benefits. Enhanced code reliability. Subtypes behave as expected when used in place of base types. Improved polymorphism makes code more flexible and easier to work with. Example in ASP.NET Core. If you have a base class shape with an abstract method calculate area, derived classes like circle and rectangle should correctly implement this method to provide their specific area calculations. 4. Interface Segregation Principle, ISP. What it means. Clients, consumers of code, shouldn't be forced to depend on methods they don't use. Instead of having one large interface, create smaller, more specific interfaces that expose only the functionality needed by a client. Benefits. Reduced coupling. Clients depend on less code, improving maintainability. Increased flexibility. Easier to evolve interfaces without impacting clients that don't use all functionality. Example in ASP.NET Core. Instead of a single iProduct Manager interface with methods for CRUD, create, read, update, delete operations, have separate interfaces for iProduct Reader, iProduct Writer, and iProduct Deleter if not all functionalities are used everywhere. 5. Dependency Inversion Principle, DIP. What it means. High-level modules shouldn't depend on low-level modules. Both should depend on abstractions, interfaces. Abstractions should not depend on details. Details should depend on abstractions. This promotes loose coupling and makes code more testable. Benefits. Improved testability. Easier to create mock objects for dependencies during testing. Increased maintainability. Changes in low-level modules are less likely to impact high-level modules. Example in ASP.NET Core. Inject an iProduct repository dependency into your product service class instead of directly using a concrete implementation like YEF-product repository. This allows for easier testing by injecting a mock repository. By following these solid principles in your ASP.NET Core development, you'll create code that's easier to understand, maintain, and extend, leading to more robust and sustainable applications.